Today we are going to be looking at doing multiple conversions involving moles, grams, and particles. So let's start with an example. What is the mass of 1.00 times 10 to the 12 atoms of chlorine? Okay. So what we're going to have to do is we are going to be starting with our initial quantity is the number of atoms, and we want to find the mass, which is going to be grams. And so our map is going to go as follows. We are going to start with 1.00 times 10 to the 12 carbon atoms. And I don't know how much a carbon atom weighs in grams. But if I'm trying to get to grams of Cl, I know that I can always go from moles to grams. That's always something I can do because I can always use the molar mass, which is measured in grams per mole, to convert between moles of Cl and grams of Cl. And now working backwards, here's the question. Can I go from the number of carbon atoms to the moles, or sorry, did I say carbon? I meant chlorine. Can I go from the number of chlorine atoms to the moles of chlorine atoms? Well, certainly I can. I can use, when I'm converting between particles and moles of particles, I can use Avogadro's number, which is 6.02 times 10 to the 23. Okay, so we now have our two conversion factors, and we're going to have now a two-step process, 1, 2, 2. So let's write out what we're going to do here. We want to find, we don't know how many grams of chlorine atoms we have. We are starting with 1.00 times 10 to the 12 chlorine atoms. And we want to convert that into, in step 1, we're converting into moles. So we need to cancel, sorry, that should say chlorine atoms. We want to cancel chlorine atoms, and we want to find moles of chlorine. And we agreed we're going to use Avogadro's number for that. Now remember, you can either have mole or you can have 6.02 times 10 to the 23. So we already have mole on the top. So the 6.02 times 10 to the 23 has to go on the bottom with the atoms. And that makes sense because there are a lot of chlorine atoms in 1 mole. There's not a lot of moles in 1 chlorine atom. That doesn't make any sense at all. Okay, so chlorine atoms have now canceled. We have our second step. And now we're wanting to cancel chlorine, moles of chlorine. And we want to find the mass of chlorine. And the relationship between grams and moles, the grams per mole, is the molar mass, which is for chlorine 35.5. Just go to your periodic table, you can look that up. 35.5 grams is the mass of 1 mole of chlorine. We do that, and we get 1 times 10 to the 12 divided by 6.02 times 10 to the 23 times 35.5 is 5.897 times 10 to the negative 11. And my unit is grams. Now, sig figs, 3 sig figs here, 3 sig figs here, 3 sig figs here, so we'd better be looking at rounding that to 3 sig figs there. So that will then become 5.90 times 10 to the negative 11 grams. That's a small number of grams, but when you think about it, 10 to the 12 is a lot less than 1 mole, so it should be quite a small number of grams. All right, let us find the mass then. Find the mass of 6.39 times 10 to the 22 molecules of chlorine gas. And I chose chlorine here specifically because we had just dealt with chlorine atoms. But now we're dealing with chlorine gas. And chlorine gas is made of chlorine molecules. So anytime you just read chlorine, if it doesn't say chlorine atoms, you can assume that they mean chlorine molecules. And chlorine is one of our diatomic elements. Remember Dr. Brinklhoff. Okay, so chlorine is one of the diatomics. So we are looking at Cl2. You should watch out for that on your test because I'm definitely going to put one of the diatomics on there and expect you to recognize it without me telling you. Okay, so now let's do our little map here. Where are we starting? Is our initial quantity? Our initial quantity is 6.39 times 10 to the 22 chlorine Cl2 molecules. Where do we want to finish? We want to finish with the mass. So let's find the grams of Cl2. Can I go directly from molecules to grams? No, I can't because I don't know how much a molecule of chlorine weighs in grams. But what I do know is I do know how always to go from moles to grams because I can always use the molar mass because molar mass is the grams per mole. It's the mass of 1 mole of a substance. So we're looking for the grams of Cl2 per mole of Cl2. And where do we find that? We find it on the periodic table and add them up. So in this case, chlorine is 35.5, but we have 2 of them times 2, and so that's going to be 71.0 grams per mole. Are we able to go from chlorine molecules to moles of chlorine? Yup, we know how to go between molecules and moles. We use Avogadro's number. So that would be Avogadro's number, which is 6.02 times 10 to the 23. All right, so let's do this problem. How many grams of chlorine is equal to 6.39 times 10 to the 22 chlorine molecules? Excellent. So now we want to cancel chlorine molecules. That's a bad line. Let's fix that line. Let's cancel chlorine molecules, and what are we trying to find? In step 1, we are trying to find moles of chlorine. Okay, where does the 6.02 times 10 to the 23 go? Does it go with the mole or does it go with the molecule? Well, remember, you can either have 6.02 times 10 to the 23 or you can have moles. So the 6.02 times 10 to the 23 has to go with the molecule. All right, we have now done step 1, check. Step 2, we're going to go from moles to grams. All right, let's convert from moles to grams. So we need to cancel our moles of Cl2. Oops, I forgot my 2 up here. That's important. Okay, and we want to find grams of Cl2. And so now we know that is 71.0 for every 1 mole. And we get 6.39 times 10 to the 22 divided by 6.02 times times 10 to the 23 times 71 equals, and I want 3 sig figs here because everything has 3 sig figs, 7.54 grams of Cl2. Let's try going the other way. How many molecules are there in 27.0 grams of ammonia? And remember, this is ammonia, not ammonium. Ammonia is NH3. It's a neutral molecule, whereas ammonium, which is not what we're looking at right now, ammonium is a polyatomic ion, NH4+. Okay, that'll be big time important for Chem 12, okay, because we deal with both of them very frequently, because ammonium is an acid and ammonia is a base. Okay, anyway, putting that aside for the moment, how many molecules are there in 27 grams of ammonia? Well, our initial quantity is 27 grams of ammonia, and our unknown is the number of molecules. And so we are then going to convert. We're going to say how many. Well, maybe I should do my map first. A map would be a good idea. So our map. We are starting with 27.0 grams of NH3, and we want to finish with, over here somewhere, the number of molecules of NH3. Excuse me. We don't know a conversion factor between grams and molecules because I don't know how much one molecule of NH3 weighs. It's way too small to measure in grams. But we can convert grams into, what can we convert grams into? We can convert it into moles of NH3. What do we use to convert between grams and moles? What's a conversion factor that has grams and relates it to moles? Well, the unit is grams per mole, and that means the mass of 1 mole, and that is our molar mass. Okay, and NH3, nitrogen, is 14. And hydrogen, we have 3 times 1. Okay, so we have 14.0, and we have 3.0, gives us 17.0. Okay, and I am being particularly careful about my point zeros because I want to have 3 sig figs here. 17.0 grams of NH3 per mole of NH3. So that's the conversion factor I'm going to use to convert between grams and moles, is the molar mass. Imagine that. Molar mass converts between moles and mass. How do you convert between moles and mass? You use molar mass. Oh my gosh, it's almost like it makes sense or something. All right, that would be step 1. Step 2, how do we convert between moles and particles? Well, that's going to be Avogadro's number, 6.02 times 10 to the 23. Okay, so let's actually do this question. How many molecules of NH3 do we have in 27.0 grams of NH3? Okay, so now we can convert, need to cancel grams of NH3 and find moles of NH3. And remember, we're converting between moles and mass. We're going to use the molar mass. That's 17 grams per mole. So where do I put the 17? There are 17 grams Now remember, when we say per mole, that means per 1 mole, right? So even though we often don't write this 1 here, if I have per mole, that means per 1 mole. So if you're looking like, what do I put on the top here? That's going to be a 1, okay? And we're going to then convert that. We now have gotten rid of our grams, and we want to convert that into molecules of NH3, and we are wanting to cancel out, our moles of NH3. And we're going to use converting between moles and particles. We use 6.02 times 10 to the 23. So that's going to be 6.02 times 10 to the 23 molecules per 1 mole. How did I know to put the 6.02 times 10 to the 23 on the top and not on the bottom? I knew because I can either have mole or I can have 6.02 times 10 to the 23. I cannot have both. Okay, so let's do this math. 27 divide by 17 times 6.02 times 10 to the 23, and we get 9.56 times 10 to the 23 molecules of NH3. And that's it. Okay, we're going to take a little break at this point, and you can go ahead and do, let's see, it is worksheet do 5.2E. Okay, that's called grams, moles, particles. And we're looking at 1 and 2-step problems. And that's on page 35, okay, and onward. 35 to 37, okay? And that's our first part of the lesson for today. If you want one more example, I am going to do one more example going that opposite direction, but if you just want to get started, you can get started. Okay, let's do another example here. Okay, how many molecules, or how many formula units? Let's do that. How many formula units of, oh, what's a good thing to have a formula unit? Potassium permanganate are contained why is it not writing? Contained in 104.3 grams of potassium permanganate. Okay, our initial quantity is 104 grams of potassium permanganate. Now, wouldn't it be nice if we had a formula for potassium permanganate? Potassium is plus, permanganate, go look it up on your table of polyatomic ions. It's -1, so that's going to be KMnO4. So we are starting with grams of KMnO4, and our unknown is the formula units of KMnO4. So in our little map, we are starting with 104.3 grams of KMN. Whoops, that should be a big M. KMnO4, and we're going to convert that into something, and eventually we want to get to formula units of KMnO4. And remember, by formula unit, we mean it's like a molecule, right? So if you want to write molecules, you can write molecules, it's fine. Okay. Do I know the mass in grams of one formula unit? No, I don't. But I can find the mass in grams of 1 mole of KMnO4. So I can convert to the moles of KMnO4. And in order to convert from grams to moles, I know a conversion factor that relates grams and moles. That is my molar mass. And the molar mass of KMnO4, I have 1 potassium, I have 1 manganese, and I have 4 oxygen. So I have 1 times, I think it's 39.1, and I have manganese, which is 1 times 54.9, and I have 4 oxygens, which is 4 times 16. So we have 39.1, we have 54.9, and 4 times 16 is 64. And it's not just 64, it's 64.0. So let's add those up. 64 plus 54.9 plus 39.1 is 158. Now, is it just 158? No, it's 158.0 molar mass. And what's the unit for molar mass? It's 158 grams of KMnO4 per mole of KMnO4. That means that the mass of, remember there's a 1 there that we don't always write down. So the mass of 1 mole of KMnO4 is 158.0 grams. So let's write that up here, 158.0 grams per 1 mole. That's going to be what we use to convert in step 1. In step 2, we are converting between moles and formula units. So we're converting between moles and, remember, formula units are a particle. Okay. And so to convert between moles and particles, we use 6.02 times 10 to the 23. So let's do that math. How many formula units of KMnO4 are contained in 104.3 grams of KMnO4? Why is it not writing? O4. There we go. And remember, in step 1, we're converting between grams and moles, and we're going to use our molar mass. So let's cancel our grams of KMnO4 and find our moles of KMnO4. So there is one, oh, where does my 158 go? Does it go on the top or does it go on the bottom? Well, the 158 is how many grams there is per 1 mole. So we write 1 mole, the mass of 1 mole is 158.0 grams. Okay. And next, what we do, we say, okay, that's great. I've got my grams. What did I want to do next? I wanted to find my formula units. So I need to cancel moles of KMnO4, and I need to find my formula units of KMnO4. All right. And when I'm converting between particles and moles, that's 6.02 times 10 to the 23. Remember, I can either have that or I can have the moles. So the 6.02 times 10 to the 23 has to go on the top, and that's per 1 mole. Let's crunch that into our calculator. 104.3 divided by 158 times 6.02 times 10 to the 23 equals, and we get, how many sig figs do we want? We've got 4 sig figs here and 4 sig figs here, but the Avogadro's number that we are using has only 3 sig figs. There is a version that has 4 sig figs, 6.022 times 10 to the 23, but we don't need to know that. But if you wanted 4 sig figs, you could change that one. At any rate, we've only got 3, so we're going to call this 3.97 times 10 to the 23, and that is KMNO4 formula units. All right. If you would like another example of this, just please let me know when you get back to class. And in the meantime, you are going to go and do 5.2e, pages 35 to 37. And come back later and join me for molarity.